2, 3 by 5. I'm doing that. I almost never ever do this. I'm going to tell you that. But I'm doing it this time. Partially because the amount of time we're spending in class seems to be, it's shrunk. I don't know if.
Yeah, we're like 7.5 weeks.
Yeah, but I mean, like in a normal lecture schedule, I know what I covered the last 2 weeks. Right now, it's gone. And time allotted. The second thing I'm going to tell you is for the final exam, it is inclusive of everything. So you're responsible for everything. And somebody, this is the questions I always get. So is there going to be more weight to the latter part? Probably. I haven't made it up. The next thing I always get is how many questions. There are probably 5 to 6 pages, each with a statement of the problem and several things you're going to have to answer. Now, this is just, if you know me, that's the way all my tests are. So there's 5 discrete problems, in a sense, a different statement of the problem, and I'll ask you multiple things about it. I've got some stuff I want to cover, but obviously I'm going to cover the thing with permutations and where you have if order matters or doesn't matter. So that for sure. Your calculators are your friends, by the way. You're going to get things with Gaussian and Rayleigh profiles, no Maxwell-Boltzmann. You will get things where you have the communication tree from a sender to receiver in parallel and series that you have to figure out. Remember the problem with 5 links, A, probability and on, B?
Yeah.
All right, you're going to get something like that. I haven't made this up, and I'm telling you, you're going to get that. You're going to get things with autocorrelation. I won't ask you to do the Fourier transform of anything difficult unless I give you the table and power spectrum or the spectral density, which is the Fourier transform of that. Now, in reverse, if I give you the spectral density, you should be able to get the autocorrelation. And I've got a few things about that. I'm trying to hit the main topics. You'll get conditional probability, and then you'll get both dependent and independent probability density. Now, if you remember the f of xy, if you wanted f of x given y, you all remember those problems, class? You're going to get stuff like this, like that's basically a density function. If I wanted f of x given y, show me that function, or f of y given x. I'll ask you something very basic about Venn diagrams. Now, what I'm going to say is, and I might as well say this right here because we haven't talked about Venn diagrams in the general sense in a long time. We talked about a specific application to conditional probability. But, you know, if A is the numbers 1, 5, 7, and 9, and B is the numbers 1, 2, 3, 4, 5. You all follow me? I'm just trying to show you something. And let's say the entire set, the entire space itself is going to be 1 through 10. Now, just trying to give you an idea. So this would represent the entire set possible. That's all the possible numbers. Now, if you think about A, I have 1, 5, 7, and 9. Then with B, you can see that there is an intersection here. B has 1, 2, 3, 4, 5. I'm just doing this. So if I give you the probability, if I want the probability of A given B, you should be able to get that. Do you remember how to do these? Pardon me? What do you always do? If B is given, I'll call this B, right? Call this A. So if B is given, it means this has happened somewhere in there. I didn't give you the exact number. You all with me? All right, what's the probability that A happened? It's this crosshatched area over what? The whole area of B. The typical mistake is they'll take that and divide by A. I'm only telling you that. This is for 2. If I had 3, then you would have 3, like a C and a D and so forth. And it's always going to be what's given, the area of what's given divided into the area that you want to actually get the probability of it occurring. Y'all with me, class? I'm just telling you that because we haven't talked about that since the beginning of the course, I don't think.
Is that kind of like the earn thing that we had to do?
Yeah. Yeah, but I mean, if this is the early chapter, do you all remember that? That was in Boncelli's book, right?
Related law to probability Bayes.
Bayes theorem, that's right. Now, the other thing, you had this on the test, but it's been a while. But I did have quite a few people that made subtle mistakes on this. So I'm just going to mention the thing with the communication link. I want to just do one of these because I see people that were unsure. If you have a sender and a receiver, we'll get to the autocorrelation. All right, now I'm just making one up. Suppose I have something like this. This is going to be A, probability of A being on. Then here, I'm going to go ahead and I'll have B, C, D, E, F, G, and something like this, where all these A, B, C, D, E, F, G, and all that stuff has to do with the probability of it operating. Y'all with me, class?
What is G? Like which line?
I'm trying to, well, I'll tell you what, let me do this. G is this one, and call it H is this one, and call this I. I'm trying to show you something that's got a whole lot of little things, but you can reduce it to something very easy. I want to make sure I've got everybody's attention, because here's what people do. They'll mess up the parallel series. They'll try a redraw, and they mess these redraws up. Remember, it doesn't matter how they look. Like if, I better do it this way so you see, because I had one girl one time really get mad that you never gave us a diagonal line. Let me do it this way. All right, there. If I drew that, follow me? Now, you can do it any way you want, but what I do, if I'm going to reduce this and get the probability of this system working, I didn't say what's working, what's not, just this system working. I don't, see, this to me seems very obvious, but do you all remember that problem? I don't know how many people, about half the people had trouble with that. And what it was is, I think, just an understanding of how to redraw the thing correctly when I made one link on, one link off, or something like that. You all remember? All right, so let's do the whole one just one time. I always recommend combine everything in series, right? You know the probability, if these are probability of working, I can just say this is CH. You all with me? So I'm going to do that right off the bat. Just call this CH, just one. And then I can see DE can be reduced to just DE. Y'all with me? All right, now at that point, yeah, you can. And what I can do is this. So that's everything as far as I can see that can be made in series right away, right? Now after that, if you've got parallel things, you don't want the probability they're working, it's not working. Y'all with me, class? So the probability of this, the BD thing, and I'm just going to do it this way. And this is what I'm up to. I want just this one for starters. I immediately go to not working, right? So this is going to be 1 minus this, right? And this is 1 minus this, correct? So the probability of it not working, this whole link right here, would be 1 minus B times 1 minus DE. That's of it not working. Therefore, 1 minus that is the probability of it working. Do you all agree with that? So, I'll do it right here. And I hope you all understand, I'm not trying to waste the time, but the biggest problem were a lot of these things where like if I put something here, then people had trouble when it looked like what what do you call those things, a delta Y configuration. Remember that? People had trouble. So this one now I can replace, and I'll just call this B, D, and E right here. So I replace it. I think most of you got this. So this is B, D, and E here. Now, what's the next step? Just take a look.
The series BDE-G.
That's right. So the only thing I'm going to do is make one thing. Now this whole thing becomes B, D, G, and E or EF, right? Single link, and it's in parallel with this one, right? A lot of this is bookkeeping. All right, so 1 minus that is the probability of that not working. 1 minus that is the probability of that not working, right? Therefore, this whole thing can be replaced by 1 minus the quantity 1 minus B, D, E, F, G times 1 minus CH, whatever it is. And now I can replace that whole thing, and I'm just going to call this K for lack of a better term. So then it's K. You agree? And after that, it's just A times K times I for the probability of the whole system working. That's it, right? Now, the ones that people kind of messed up were the delta network kind of stuff. So if you have this, and I'm going to do kind of a different one. If I have this, well, wait. Yeah. That'll do it. Let's say the probability of them working are all the same just because I'm not messing around. They won't be probably on the final. All right, so how do you do it?
I guess you can start off by assuming either.
Can I make a suggestion?
Yeah.
Any kind of problem that looks like you can segment it down to smaller chunks, do so. What I'm going to do is this. I can see that this is identical to this. First, you have to be able to see that. All right, after that, I just isolate. By the way, if I have the value for the probability of this working, I have the probability of this working. Because of symmetry, they're identical. Now, they won't be probably on the final, but I can't say that. So I haven't made it up. And usually when I'm picking up the final, I look through the homework, I look through the quizzes, and I try to find something that is like a permutation of what we covered in class. I don't try to make these things just off the wall. All right, for that, let's start with just one. What about this one? I just want it from here to here, all P. So how do we do it? Now this is the part where people made the mistake, but it's obvious.
So given P working, solve for that, and then
Here's
given P not working, solve for that.
Yeah, here's what we do. There's a couple ways to do this. First, assume it's not working, right? So if it's not working, I have 2 in series, right? So the probability, this becomes just P squared, this is P squared. So if I have 1 minus P squared, that's the probability of the top one not working, right? 1 minus P squared is the probability of the bottom one not working. 1 minus that, or really this, is going to be the probability of the system working. Do you agree with that? You got 2 in series. That's what I was trying to go for. Forget this leg right now. You're just going to have another, just like that. You all with me, class? So if I take that and just square it, Now I have the probability of the system working. Agreed? With stuff like this, here's where it gets complicated. What if somebody does this? Huh? Now, I'm just going to tell you something. Anytime you,
It would just be in parallel with whatever you solve for.
well, this is the thing you have to understand. This and this are parallel now, right? But here's the way you do it. I'm just telling you. Always take a look at these middle legs, right? For this one, the probability, I mean, that's, I didn't finish this problem. That's what we get, sorry. This is the probability of this thing working, right? Given the center one isn't working, right? So it's 1 minus p. Y'all agree with that?
Where's the extra square coming in? Because you
Huh?
squared.
No, because the top one, just look.
Oh, no,
This is,
on the outside, you have it squared again.
yeah, because there's two of them over there.
Oh.
All right, here, I'll take it back and just focus on this one, sorry. All right, now, I didn't finish this one. I'm thinking about things, I'm just gonna focus on this. Does everybody agree that this would be the correct probability for, now remember, there's a middle bar I erased, right? So now I put the middle bar in here, assume it's working. Look, when it's not working, we get that. That's what I was getting. That's the probability of that, but times the probability of this not working is 1 minus p.
Yeah.
No? You see it or not? Look, if it's not working, this is the system, correct?
Right.
All right, so that would be the probability right there of that system, right? Well, for that configuration, what is the probability of occurring? It's 1 minus p, because p is the probability it's working. I mean, of this middle leg working. Do y'all follow me? Now we put it back in. We have that, right? It's a different configuration. This is just for this one. This is going to be p of it working. So for this one, for that one right there, what do we get? Do the redraw. It's working, right? That's what we have, right?
The top one you said was,
Say it again, Trey. I mean, Nick, what?
I'm still so confused because that 1 minus p at the end.
All right, follow me on this.
I don't know why you put it there.
All right,
because you
look,
already
if
have
this
it.
is probability of it working, right?
Okay.
I'm going to show you what this is equal to. This is equal to this configuration. I'm just doing a diamond, right?
Yeah.
P, 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 P.
That's the.
That's this right here, right?
Yeah.
But it's also times the probability this middle leg right here isn't working.
Okay.
You all follow me on this?
Yeah.
Yes.
So this is going to be times 1 minus p. So it's that plus, and then when it's working, it looks like this. Now this is a short, right? And this is P, 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 and P, correct? I'm glad I did this one. You with me? Well, what does that look like? That looks like
Yeah.
P in parallel with P, right? And then P in parallel with P here. And we want this. So what is that? Remember, you're going to multiply that by P. You all follow me? You see this? James, or no? You see how this redraw corresponds to this? That's working. Right? So, do you agree that's that? All right, now this one, the probability of it not working is 1 minus p here. 1 minus p, because they're in parallel, this is 1 minus p and 1 minus p. You can see that frankly when I get the probability of this one working, I can multiply, I can square it, right?
Yeah.
All right, what's the probability of this one working? Well, it's going to be what? 1 minus p squared, right? And then you have 1 minus that. That's the probability of that one working, right? It would be ideal.
Then you have to square that. Because you have
Yeah, you will. Now, this one is identical to that one, so I would square it. But then I'm going to have to multiply that by p. Because that's, so then I'm going to say this whole thing is going to be plus, what do I have there? 1 minus, you can see the symmetry, 1 minus p squared, right? And this whole, yeah, p squared squared times p. And that would be the probability of the system working.
But you also have to,
Say again?
you have to square the top into
The what?
Oh, yeah,
the
yeah.
top one.
The top one you have to square because remember you only did it for the one.
Oh, you mean for the total one over there?
Yeah, yeah, yeah.
No, up top.
Here?
Yeah, you have to square that bracket. Right?
Why?
Oh, wait, no, that's
Because you
just
have
for a
the
single.
single.
We only do.
Nah, he hasn't added it yet. He hasn't added the second part yet.
This is, no, this one here is for, it's basically for this one, right?
Right.
It's p squared on top, right? So 1 minus p squared is the probability that the top one not working. Squaring it right here is the probability
Bottom.
of both of them not working, right? 1 minus that is the probability of it working. You all with me on this?
I see what you're doing now. You're just doing.
It gets
one side.
confusing if you don't, you gotta,
You're just doing one side.
yeah, and those are the things that drive people nuts, by the way, right there. Okay? So that's the way you would do this problem. But for any of these problems, whenever you have a configuration and you want the total, suppose this one looks crazy. So here's what you do. Just listen. We just got this, right? Y'all agree with that? And you'd multiply that, you'd square that whole thing if you had two of them in series. All right. Now, if you have that, well, you know the probability of this happening, right? That would be that, this whole business, the P of W squared, right? Because there's two of them in series. Now put this in. Now it's working. Now take a look at this, what happens. What really happens? If it's working from here to here, it's a short, isn't it? All right, now, I got a question for you. If that's a short, I'm trying to show you this. If this is a short from here to here, does this leg matter? Let me do it with terms of resistors. If you have a resistor R, and I do this, what's the net resistance across those 2 points? 0 if it's a short. Do you all follow me on that? So this thing would be, this whole thing from here to here is working. Y'all follow me? All right, it's essentially the same point. As a matter of fact, what you can do is this. This redraw is going to get kind of crazy. Now all these are working here, here, and here. Now just take a look at this. If for this one right here, this is a short. All right. If this is working from here to here, effectively this point, you could draw these two in parallel, right? Now, now this one, you can see how these two in parallel are going to be 1 minus p squared, 1 minus that from here to here. You all with me? And you got that in series with p, and parallel with p. Over here, you got basically the same thing. And from here to here, from here to here, I'm trying to say this. Here's what I should do. Do a redraw like this. Now you got that. Y'all follow me? I'm trying to show you the redraw and how, make them vertical, it's a little more obvious. These two are parallel, right? That's 1 minus p squared, 1 minus that is that leg, right? You got that in series with p in parallel with the other p. And a lot of it just is bookkeeping and keeping your head on straight. Make sure you stay focused. Because if you lose focus, think of it, you got to be a very good accountant. Think of it as your bank account. You could lose a lot of money. Something to get your attention. Because you can mess these things up and boy, you can get in trouble. Yes?
So when going back here, you said that the probability, the total probability of it working is PW squared. Would it not be?
Whoa. Of what work? No, because this is only, hold on. We had two of these.
Yeah.
Let me draw that, because I'm erasing a lot of stuff.
Yeah.
What I'm really saying is that pertains
So just one to one side of it.
to this,
Right. And if you were to
just this. If you put another, that's exactly what I'm trying to say, I got a replica. I've got
so it would just
this.
be PW squared, right?
Yeah, that's P, yeah, this quantity squared,
Yeah.
that's what I'm trying to say.
Yeah.
That's all it is. But a lot of this is just bookkeeping. And it kind of is maddening. Look, if you're in accounting, especially in graduate school, they'll give you problems that are massive in terms of the number of things happening. And you have to do it in a very orderly fashion. Like everything can be done sequentially. You do the addition, then all the things where you compound interest and stuff like this. You have to take care of all the little things very carefully. That's sort of like what these problems are. It's not hard conceptually. The difficulty is keeping track of everything.
Would that be like considered a law of total probabilities question?
Well, yeah, but yeah, actually, I guess
Because it's like,
it's
given this is off, like, or.
I
given this
didn't
is
do
on-
that though. I mean,
Well, I mean, basically, right, because given this is not working, plus
Oh,
given it's
yeah,
working.
but this, yeah, you're right, but it's the total probability of the thing. So it's, I guess it is the fundamental law of statistics and probability.
Okay.
But the real thing, now what I'll probably do, I can't say, I'll probably say, okay, this one isn't working.
Yeah.
All right, now tell me what's going on. Or this one and this one aren't working. So you gotta do it again. I'm trying to level with you guys. They're not hard conceptually. The bookkeeping is what kills you in a lot of these. And you can't lose focus because you'll. And I know when I'm thinking about things further down in the class, I can sometimes get too casual and just not pay attention. I can miss things. And I know students do that too because they're looking on the last part of the exam is the tough part. And their mind wanders from the problem at hand. By the way, does anybody have 3 exams on Wednesday? Okay, if you did, you would get to either take one of mine later or whoever the other guy is, you could ask him, because you're not supposed to have 3 exams in the same day. At least that's what the rules were before it went to 2-hour finals.
I kinda wish they wouldn't let 2 exams on the same day for engineering.
They let one?
Like, I wish that you couldn't have 2 engineering exams on the same day.
Oh, yeah.
I wish
We've got 3 final days.
engineering was kind of its own entity, where we could have our own final days.
Hey, normally, a normal load is 5 courses, and finals are usually 3-day period. You're gonna take 2 on some day. You just are, if you're taking all engineering courses.
I just would think we're at the same time as our classes.
What?
I do all of our exams at the same time as our classes.
You know why? Because they're 2 hours. They can't, or there'll be overlap.
Yeah.
And that's the reason. I mean, there's weird ideas about some of this stuff, but if you go to the Ivy League a lot of times, MIT and stuff, I mean, there'll be 4 or 5 hour exam periods. And they'll take a lot of them at night. Have you ever had nighttime finals or nighttime exams?
Yeah.
The chemistry one's at 7.
What the?
7,
All the,
At 8 o'clock, calculus
All
3
calculus.
class.
Physics.
I never liked nighttime finals.
you sit there and stress all day about it.
And then you go in all night, have an 8 a.m. final the next day.
Yeah, it's the athletes are the ones that really suffer if you have jobs, because they
Might as well just take off all problems.
final exams are very important. If you know how the British system is, anybody?
Like A levels?
What?
Like A levels?
The collegiate British system. There's a book called The Masters. Some of you guys should read if you're going to grad school. What they do, you don't get any exams until the end of the first 2 years. And then you get a battery. It's only comprehensive. If you don't understand stuff long term, they don't care. I mean, they could care less about short term memory. And they're thorough. It's a very difficult set of exams, but the kids that come out of that are very, very well, I guess, educated, and they're ready for their field. The Masters is a great book, and it talks about how these guys, by the time they're done, this is a mathematics program. Anything that they get in the real world seems trivial. It's like going through Marine boot camp. After that, combat's trivial. If you can survive the boot camp, don't worry about it. You can survive anything. But it's a much different system, and very few people that I know that aren't raised in the British school system, maybe some Europeans, that went there, that went to like Oxford or something and stuff with science degrees or Cambridge, they're not used to preparing long-term for tests that are so comprehensive. It's an interesting way to do stuff, but they do really get some brilliant people.
I bet I can cram the day before. 2 years long test.
You gotta read about it. Some of this stuff, I mean, they expect these kids to do all this, Bessel function expansions, all these other things, and no, they do. And you know, people do. They will, in many cases, if they're capable, they'll get that level of understanding, but it's very difficult. They're spending 10, 12 hours a day doing that for 2 years because they know, a lot of these guys know how important it is for their career. If they don't make it, they're going to be flipping burgers or something. Anyway, that's another story. Have you ever had people from England teach you English professors?
No.
Oh, I've had. They're amazing. German and English professors are the most demanding I've ever had in my life, and there was no forgiveness. A lot of people.
Sounds like it sucks.
They're just making you mature. I mean, there are people who don't want to grow up, but I mean, that's the real world. In the industry, I mean, there is no forgiveness. You mess up, you're gone. I think, who was it? Steve Jobs? You know who he is?
Yeah.
He's kind of a well-known fella at one time. Anyway, he was the guy that would just go down and fire people on the spot when they messed up. He had no mercy. He said, you cannot tolerate any kind of subpar performance. Just fire him. He was not loved.
Heard no one wanted to ride the elevator with him.
But look what he achieved. All right, now I'll take questions from you. Those are two things I'm going to do something with autocorrelation in a second. Now I gave you one autocorrelation thing. Yeah,
What
but
time is our exam? Like the same time?
8 a.m.
it is 8 a.m. Wednesday. That's what you're living for, I know.
In here, right?
Huh?
In here, right?
Yeah. The exams are always in the same room unless otherwise stated.
Oh.
And I want to tell you one thing too. I hope everybody has each other's phone number. So if somebody doesn't show up by some act of God, like power going off in the alarm, that we can call you and wake you up. Because I've had people sleep through exams. Oh, that's a tough one too. You sleep through a final, you get an F. And there's nothing you can do. I mean, I can't do anything. All right, questions besides that?
It's not a correlation.
How about we do that problem? You remember the one I posted? Did you all see it? Have you looked at it? Seen it, Keenan?
Homework 17?
17. Like,
There's nothing on
There is one.
He added a
Yeah.
layer.
16.
It wasn't like yesterday.
Yeah.
I put something, I checked and I made sure it was there last night.
It was late on Saturday. I didn't check.
Yeah.
Yeah, it's here.
All right, just read it to me. I want to do it with you because autocorrelation is something that's very easy if you understand it, but it's very difficult if you don't.
An ergodic random process has an autocorrelation function of the form Rx of tau equals 9 e to the negative 4 absolute value of tau plus 16 cosine 10 tau plus 16.
Okay. This is a good one. It's out of the book, by the way. All right, so what's the first thing they ask for?
Find the mean squared value, mean value, and variance of this process.
Those are 3 questions. You're going to get something like this on the final exam. It's not hard. So the first thing, I mean, how would you tackle this, whether you studied it or not? There's the very first thing we're going to get is the mean squared value. Does anybody know?
Well,
How about Keenan? We'll call on him for once. How do you get the mean squared value? It's what? Rx of tau equals 0, isn't it?
Yeah.
Has to be the P for a legitimate autocorrelation function. You agree with that?
Which question was this, by the way?
It's the one I posted.
Yes. It's
It's
exercise 3-1.
By the way, I'm sorry that didn't go up earlier. That's on me. So what is that? Just look. All right, tau equals 0. What's this one?
It's gonna be 9.
This one, tau equals 0?
Where is the tau?
Tau is 10 tau, just 10 tau, cosine.
So
What-
that's
when
0,
tau-
what's cosine of 0, 0, right?
1
1. 10.
plus 16. Now see, their answers are there, I think, aren't they? I don't know if they're all right, but,
Yeah.
all right, what do we got? We got 26 and 9, is that right? That's 20, unless we do.
26 plus 9, 20, 30.
Wait, why is it 10? Then
Oh, I'm sorry, 16. This is a 16. 16, my bad. It's good, my writing's horrible. Are you with me on this? So we got 16, 16 is 32, this looks like 41. Is that an answer?
there is an answer 41.
All right, we maybe, we'll do the next part then.
Yes.
All right, so what's the, now, hear me, how do you get the mean value?
You're going
Tau equals what?
with.
Now, think about what this is. Rx of tau, just listen to me for a second. By definition is the integral of 1 over t from minus t over 2 to t over 2 in the limit as the period goes to infinity of the actual function x of t, these are random processes, x of t plus tau, right? You all with me? Now, think of a process, it doesn't matter what it is, any process at all. I'll make it something time limited. If you see this, what do you know the DC value is if it's constant forever after a certain point? It's this value, all right? Because in the DC value of a power signal, something you have to average over all time, is just going to be this value. Well, how do you get that value from this? Right here. You take the limit, this is d, sorry. This is going to be dt. You take the limit as tau goes to infinity, right? With me, class? And then you divide by that. So what it amounts to is this, and that'll be x squared, by the way. X bar squared. So this is going to be the square root of the limit as actually tau goes to infinity of Rx of tau. So what's that going to be? As tau goes to infinity, you can see that this thing oscillates, right? Can you all see that? What I'm really going to say is, technically this one would be, that is a cosine of 10t, right? Is there another exponential in here or not?
No.
Yeah. Let me take a look at this. Because this, technically, if you have this oscillatory property right here, this thing, even if it oscillates, you can technically ignore it. Do you all see how the cosine is going to just bump up and down all the time? And it would be this. It would be 16, but we didn't get into that. But you can see that this thing oscillates all the time. What is the average value of a cosine waveform, by the way? 0, right? Cosine of theta, same area
So
above,
the x bar should be 16, no?
It's gonna
x
be
bar squared,
Okay.
right? Y'all follow me?
Oh, yeah, okay.
So really, you're going to take,
So x bar should be 4.
so this is going to be the square root of, what, 16? Now, you can only get the magnitude, you can't get the polarity, so it's plus or minus 4. And I think that's an answer, but don't quote. Is that one of the answers?
Yes.
So it's plus or minus 4. Now, what else they ask? The standard deviation, right? Or variance. Now, the variance is a straightforward operation up to that point. If you get the first two right, the third one's a gift. What do we do?
You have to x bars.
X squared bar minus x bar squared. So it's the mean squared value minus the average value squared. And what is that? 41 minus 16, right? Isn't that right?
Yeah.
And what do you get? 31 minus 6 is 20, what?
25?
It's 20, it should be 25. Is it plus, is that one of the answers or not?
Yeah, it's no, not one of them.
Don't be an air traffic controller. Can I land? Yes, no.
We have 33.
Now, don't worry about that second part. The second part has answers there too. See, there's two parts.
There's 33, there's 41, there's 6. plus or minus 2.
That's per second. But what I'm gonna tell you is that if you have x bar, right, x squared bar, right, and you have this has to be the value. Do y'all follow me? Okay. By the way, you know what? I decided, I put some things in Chat GPT and I found problems to give the wrong answer and problems to give the right answer. I haven't put this one in there, but I'm gonna see what they come up with. Because it's sometimes, huh?
That doesn't do math right.
You could give ChatGPT the right answer and it'll still do the
Well,
wrong.
sometimes
Yeah,
it'll do it
sometimes
wrong,
it
and then you
asks you
regenerate,
to
it'll
do
do it right.
That's funny.
Yeah.
Yeah, and sometimes you just go back, you did it wrong. And they're like, oh, sorry, then they'll just do it right. Or it'll do it the exact same way it just did it. Like, let's do it again.
I guess AI is
I use
still,
it as an arbiter to check the
Chat is
book.
random.
I check my work, books work, and then I use it as an arbiter. I'll check the books work, I'll check my work, and then I'll throw it in ChatGPT.
okay.
Can you explain the X bar again?
Yeah. All right, come up here for 1 second. And I think you'll see. So if we take this right here, if you want, how do you calculate the average value of anything? If I wanted x bar for anything, it's what? It's the integral, right? Of, I mean, this is a signal that exists for all time. It'd be from minus infinity, well, technically it's this. From minus t over 2 to t over 2, 1 over t, if this is time limited, and it's going to be x of t dt, right? That's the average value, right? All right, now what is the average value? Huh? Oh, thank you.
Just got his megaphone voice out right outside the classroom. He's telling about his whole thing. He's talking about some nitrogen. He's talking about nitrogen, he had like a milk carton. I don't know what is going on.
Here's what I'm trying to do. I hope this works. If I take a look at just the average of x bar, and I'm putting a 1 over t, it's 1 over t, the integral from minus t over 2 to t over 2, x of t dt, right?
What is the x of t?
A function, it's a random process of time. Anything, you with me?
Is that the same
That's
thing as
this.
our R at?
No. That's, Rx is this, it's the two multiplied together by a difference of tau.
Okay.
You with me? Now, just, if you look down here, first, do you all agree that just x bar, the average value of a function x of t, a random process, would just be that? Do you all see this? And you would take the limit as t goes to infinity, but we don't need to at this point. All right, well, if I wanted this value squared, it would be this times that, right? Now, what happens if I do this? X of t minus or plus tau, and it's still going to be dt. All right, and take the limit as tau goes to infinity. Hear me?
Yeah, I see what you're saying.
All right, look, that is still going to be the DC component because it goes from minus infinity to infinity. This is still going to be the same thing as this because now tau doesn't matter, it's going to infinity. You all see that? So you're going to get, you get that value right there, or this value as tau goes to infinity squared. As tau goes to infinity, this goes away. As tau goes to infinity, this is the thing, this is oscillatory, ignore it. The average value of a cosine of 10t over any period is still 0. It's just the square root of 16. That's how you get that one. Do you remember this stuff at all, or not?
So,
Anytime you have a cosine or a sine, any periodic function, the average value of that technically is 0, even though it's undefined, because if you take the limit
Yeah, that's what I.
If you take the limit of t going to, or tau, pardon me, going to infinity, right here, of the integral of 1 over t, well, actually, this does have a limit, does it? if t goes to infinity, if I take that and I say from minus t over 2 to t over 2, take the limit as t goes to infinity of any a cosine of omega t dt, this is still oscillatory, right? But this is going to 0, so it's 0. That's my point on that one. It's oscillatory. Now, if it was squared, it's different. Then you will get a value. Make sense?
If it's cosine squared?
Yeah, sure. Cosine squared can be broken into what? 1/2, right? You all remember? You're going to get a 1/2, and you're going to get cosine really of 0, or 1/2 plus 1/2 cosine of 2 omega t. If you do, well, the 1/2 is 1/2.
Yeah.
Cosine squared has a value. But cosine of omega t or cosine theta, in the limit as theta is going to infinity or as t is going to infinity, it goes to 0. Anyway, the answer should be plus or minus 4 for the average value on this one. This is square root of 16. Now, and the variance, unless I did something wrong, is 25, and I hope that math works out. I think he subtracted the wrong numbers if you want the truth. That's what I think happened.
Maybe the first time.
Yeah, I was gonna say, he does that a lot.
Things happen. All right, now, what's the next problem on there? Just work with me.
And ergodic,
Ergodic.
Ergodic, and it just means wide sense stationary. Anything previous is nothing to do with the outcomes of the future, and it's a, quote, random process. No matter where you sample x of t, it's like flipping coins at that point. Think of it as that process is random at all time. Anyway, go ahead.
has an autocorrelation function of the form,
Go ahead.
oh goodness, f tau squared plus 6,
Wait. F?
4,
Oh, 4.
f tau,
F of tau?
just 4 tau squared, 4 times tau squared. I get my 4s and f's.
That's all right, go ahead.
Plus 6 over tau squared plus 1, or the whole thing's over tau squared plus 1.
All right, hold on. 4 tau squared plus 6, did you say?
Plus 6, yeah.
Over
All of it's over.
the whole thing?
Okay.
Okay, over what?
Tau squared plus 1.
Oh, this is a good one. Okay. So I want you to just think of what we did, and let's see if we get it. What? First of all, is that an even function? Has to be even for a legitimate. Remember those things? Even, can't have flat tops, can't have vertical walls, right, for non-calculation. And that one checks boxes, right? Take a look. You all agree?
Yeah.
All right, so now, first thing, how do I get the mean squared value?
Volume 0.
For what?
Tau.
You all agree? What is it?
6.
All right, now get the average value.
Well,
This, you take what? The limit as tau goes to infinity of this will be equal to x bar quantity squared, right?
is that the AC?
I hope so. That or we're really in trouble. You can open the doors if you want. I don't think there's any racket, but it's your choice.
Okay.
Should be square root of 4.
Is
Well, what is this? It's going to be, this is tau goes to infinity. These two terms don't matter. Tau squared over tau squared. If you're wondering about it, just divide top and bottom by tau squared. Look, if you divide top and bottom by tau squared, you get this. Then you get 1 plus 1 over this tau squared. If tau is going to infinity, that term and that term, they're gone. So it's really going to be 4 over 1, or this is plus or minus 2. By the way, is this one of the answers and that one of the answers?
Yeah.
Yes.
That's what it is.
Y'all with me? All right, what's the last part?
Find the variance of this process.
All right, so what's this? Well, I sure hope it's x squared bar minus x bar squared. But anything's possible, so that's equal to 6 minus 4 or 2. Is that one? It must be one of the answers. All right? Now that's the kind of problems, that's obvious, right?
See, if I have to give you ask you to calculate the autocorrelation from two mathematical functions, you almost have to have trig identities. Not always, but suppose that, let me do this one. Why don't we do it? Let me erase this, show you the one I'm thinking. Let's try to think of good examples that aren't too difficult. Oh, has anybody been watching the Olympics? I have it on TV and I'm doing stuff, but most of it I could care less about team badminton or whatever, but I watched some boxing matches and they changed a lot. They don't have headgear anymore. Boxing used to have, they paint the front part of the gloves so only the white part, if it hit, was a point. Now it's like plain old street fight. Sweet. I mean, it's like,
breakdancing to the Olympics.
No way, that's sick.
they have skateboarding, I didn't say breakdancing, and they have mountain biking.
At this point, they're just adding hobbies.
You wait, there's gonna be pickleball next Olympics. Don't laugh, they have Their pickleball is the fastest growing sport in the world.
It's fun.
In the world?
In the world, look it up. I mean, growing. Soccer is the most popular sport.
Well, yeah, no, but
Do
like,
you play pickleball?
growing.
No, I play tennis. I'm a tennis.
I play tennis too.
I love tennis. Pickleball, I don't like for one reason. They're always on my court.
We should play
I'm
tennis
level
one
with.
day.
I'm level with you. I go over there. They're playing pickleball on my tennis. Get it out. But, I can't
We should play
say
one day.
what.
We should play tennis one day.
No, I don't want to get clobbered. All right. I've got sciatica. I can barely hobble around. No, I do play tennis, but I'm trying. With this thing gets better. But I've had kids that I thought they're club tennis players. I mean, these kids are 5'0" and up. Unbelievable.
I haven't played since like senior year of high school.
We'll probably come back in a heartbeat. Okay.
Serves getting better.
You ready? All right, here's a random process. I'm going to say x of t is equal to e to the minus 5t u of t. So obviously, it's only good for t greater than 0, right? Y'all agree?
Yeah.
As a matter of fact, let's do it this way. Make it absolute value right there. That way we can't mess up. Now, I want you to give me the autocorrelation of this, of x. I'm sorry, of tau. So how do you do it? I don't know if you remember the definition, but I want to do this one. Hold on for 1 second. What's that?
1 over tau, the big S. Tau.
I'm going to do it here.
Integral.
Rx tau equals, put the limit, try as t goes to infinity. Tell you what. Let me check one thing. I want to do one because you know what?
Yeah. 4-3. 4-3.
I want to check one thing. Are we missing anybody today?
No. Listen to this guy. Oh, have you ever seen that guy?
He dropped.
Oh, Don?
Trent Grom.
The Asian guy.
Yeah, we're missing.
Oh, fun lead.
Oh, yeah. He is not. Is there another test in the class or something? He rarely misses. Oh, he might have thought,
Maybe he didn't get the.
We sent something in the group too.
Oh,
He's a groupie.
You just don't be checking his phone like that, I guess.
As long as he makes a day log, it's his picture.
Yeah.
he's in my EMAT class.
Yeah.
So either, if somebody can text him and just let him know, we do have
Maybe he's
classes.
submitting a project. He wants to. He's actually.
No, I talked to him. That's was you good project? He's like, yeah.
And so hopefully he's there.
Yeah.
Because otherwise he is doing the project and he's getting a 0.
Oh my god, correlation isn't that hard. It's just daunting.
But it does require some focus.
All of these require focus.
But you won't put an autocorrelation on a final though.
It will.
He already said
I double start it.
Guaranteed.
Hey, look, that's good though.
You're gonna, the half the test is gonna be questions about new stuff, right?
Brendan, I don't know. I haven't made it up.
It will be though. It will be though. You tell us how it is.
4, 2, 4, 3, 4, 4, 6. In the test.
The late problem.
I'm cool with that. Okay. It sounds good.
Hey. I have to give you a random process.
Week problem.
No, that's too easy.
I'm talking about like.
A 14 branch.
Oh yeah.
Look at this giant. Did y'all have circuits when Erwin, he put this huge problem on the test, and it was like all like a 10 resistors just mumbled together. And there was like one short circuit in there that powered up all of them.
I tell you what, for me to do this, for me to ask you to find I have to get a random process. So let me just tell you this, because I'm not gonna ask you this right now, we didn't have time to cover. Normally they say you have a random process like this, and they'll say this width here, and I'll just call it tau, period t. The width tau is a random variable, and it varies from, say this is 2 pi, from 0 to 2 pi. You all with me?
Yeah.
Now, that means when you sample this is x of t at any point in time, and the distribution will be uniform. Then you can get the autocorrelation, but I didn't have time to go through that, so I can't ask you that in detail. I won't ask you to calculate the autocorrelation.
Thank you.
But I will give you an autocorrelation and ask you things.
Yeah, we've already done that. It's easy.
Yeah, but I'll tell you, you did it for some simple ones, right?
He's been here all week.
Hard, bro.
He's well rested. And
You said something about spectral density,
Oh,
That's
yeah.
the Fourier transform of this,
and
of the autocorrelation.
are you going to?
If I ever gave you one of those,
I don't know.
I'd make sure it's very difficult, and I'd tap Bradley as a thank you for
So that means if we
I'm not
get it
gonna
wrong,
give you one.
It goes on Bradley's grade.
You can
So,
go.
so I'm fronting everyone. I'm fronting everyone on this particular question. Is what you're saying. The points that they take off goes off me first.
It's done for you.
No, yeah.
No, it has to be.
No, even if I get it, if I get it right, it has to be perfect, and I'll still get knocked because I'm fronting everyone else.
Here's what I'm getting at. Suppose I gave you this. Now, we had things mathematically, right? Here we go. Suppose I say this is Rx of tau. Versus tau. Now I want information from that. So you have to take a plot and create a mathematical function. You all with me?
I mean, in theory.
Generally speaking, if you can do it better than that. So, but you can also look at it. Remember, if this is Rx of tau, just looking, what is the mean square value, Bradley?
Is it just
Think about it. How do you get that? You let tau become
0?
and evaluate the function. What is it?
A.
Well,
Is it 4?
it's supposed to be a 4. It's 4a, right?
Okay.
What is the mean value?
2.
Area under the curve.
the mean value would be
What is the value of Rx of tau as tau goes to infinity? 0.
Oh, okay.
There's no DC component.
Okay, gotcha.
These are things that I'm doing for you because that was a mistake right there.
Yeah.
Alright, what's the variance,
This is gonna be 4.
right? Ready for part 2?
So, this one has straight lines though.
No, you can have straight, not vertical lines.
Oh, not vertical.
Not vertical, not flat. Top can't be flat, right?
That makes sense.
Alright, what about this? Now, an autocorrelation function can be negative, but the Fourier transform of it is strict positive. And I'm not gonna, we didn't cover that, but I'm just telling you this. So if this is tau, and this is Rx tau, and let's say it does this.
Is that 8?
Yeah, it's supposed to be. Okay? Now, without writing a mathematical function for it, what is the mean squared value? Just look.
8.
Right? What's the average value?
4.
Square root of 4.
Square root of 4.
Plus or minus square root of 4. That's a typical mistake. All right. Now, what if I give you, trying to come up with this where you can actually read what I'm drawing. Let's try this. Bashir used to give practice exams and stuff like this. They were just basically problems out of the book. Frankly, I think this is a little better because his problems on his test, from what I looked at, weren't that representative of what he gave his practice. And you sat through that class, didn't you, Keenan? Is that a fair statement, or is that just me? I mean, I looked at his test and I looked at his problems, practice test, I'm like, I really don't see it. Okay, you ready?
Yes.
Austin Thornton, oh, come on.
Right here.
All right, this is 16, right? This height that is repetitive is 4. The negative part is -2. Okay? All right, first, what is the mean squared value?
16.
You all see that. But what do I need to do? I mean, I would write a mathematical formula. Say this is a cosine waveform,
It's 0.
but that's -2. That's 4. So what do you have? Well, if you have a cosine waveform, I'm trying to really help you guys too. The spread on that is 6, right? If you think of a cosine waveform, it would be 3 minus 3 would be the spread, right?
Mhm.
But it has a DC offset of what?
1 plus 1.
So if you had what? 3 cosine of say 4 tau, right? Plus 1. Y'all follow me? That would represent this. What's the average value of a cosine over
That's 0. And then plus 1.
plus 1 would be x squared. What's square root of 1?
Plus or minus.
Plus or minus 1. Y'all with me, class? Trying to show you stuff that you could get messed up with, because not knowing how to resolve that into 2 parts can mess you up. Now, it doesn't have to be that. It could be this. It could be a triangle wave like that. Y'all follow me? Then you would have to resolve that into 2 functions. You with me? But you have the capability of doing it. You have to think through it and not panic. That's the only thing. All right. Y'all with me? I'm trying to show you things like, these are things that, yeah, Brent.
So what would be the DC offset here in this example that you gave? It would be
For
-1?
what?
You said like something.
Triangle wave?
No, for the one where it's 16 -2, 4. What would be,
See this?
yeah.
Isn't this represent, I'll call it x prime of t, it represents this part of the waveform, isn't it?
Where the trough is -2 and the peak is 4.
But I'm saying this is tau, part of tau, right? And what's the average value of that?
0.
1.
Or one, yeah.
Alright, but that's means, or it's the average value squared, isn't it, class? So you take the square root of that. Y'all with me on this? It's not meant to be difficult, but you have, if you understand the theory, you can scrutinize the thing and come with a reasonable answer.
Yeah.
If you don't understand the theory, it's, you never covered it in class. I used to get that a lot. Because for some reason, taking a visual plot and turning it into a mathematical function is a big challenge for some people, especially straight lines for some reason. I never understood that. You know, generally speaking, it's what? Y equals mx plus b. Y is the vertical component, x is the horizontal, b is the DC offset or zero offset, right? But you won't believe the problems that I get on that.
So if it were straight lines,
Be the same.
it would,
What do you
Because
mean?
it's still oscillating.
It's oscillating.
yeah.
You'd have to find what? You'd have to find a mathematical function for the oscillatory version, right?
Yeah.
You can reason this out. Or not even a mathematical function, just draw it plus the DC offset, right? These aren't hard. They just require focus, in my opinion. Some of the things that I've seen though, there's a book called The Pullist. That's challenging. I remember having it. I was studying that. We had Larson and Schubert. And when I was a senior, we had to take this course. And by the way, that course was rough. A lot of people failed it. It was a very good course, but I remember I spent a lot of time with that stuff. All right, we're about done now. So, any other questions? I covered the problems. I wanted to do a Venn thing, and I wanted to mention the stuff with the links, because those are, you've had problems with links. You didn't really have problems with Venn diagrams that I remember.
We did at the beginning.
Yeah.
We had a lot of Venn diagram type problems.
No, but you didn't have difficulty.
Oh.
People did it well, is what I should say. You had the conditional probability. Most of that stuff I think is straightforward. You've got plenty of problems on that. So I'll take any question before we break.
So the ones where we had like the bottles of wine and the permutation.
There's permutations and what combinations, yes.
Is that kind of, is that stuff?
You get one on that. I mean, with those problems, if anything,
It's like
Teasers.
n factorial over k.
n factorial over n minus k factorial for what? Permutations, combinations, right?
It multiplied by like.
No, it's n factorial over n minus k factorial divided by k factorial.
And for convolution.
Correlation.
Convolution.
Yeah, okay.
Yeah.
This
Can we
is
expand that?
What, correlation?
No, convolution.
For what problem? Show me, tell me the problem.
Like the
One
one
on
on
the
the
test.
the one we had on the test.
Yeah.
Like where it was
We
like.
have to, you have to find the Z.
Oh, yeah, but that's just, that's conditional probability.
Okay, when
Right.
find it, well, I'll just.
F of z, yeah, you get z equals y plus x, right?
Yeah.
Find the probability, or find the density function for z. Yeah, sure,
So
that's fair.
finding the bounds though
Yeah.
for your z function, I still haven't really got a grasp on.
You have a specific question? Because I'd be happy to do one.
We can do on the test.
Okay, let's just do the one on the test. You don't have to go all the way through it, it's just.
I didn't even know how to get the balance.
Yeah.
That's what Tristan gave me.
Yeah, so I understand shifting the function around.
You know how to do convolution, right?
Yes.
Well, let me just draw the function and show you how to convolve, because that's the real question.
Yeah.
The limits are shown right there. Hold on for 1 second. I'll try it.
I understand the limits of the integral, I just don't understand
The limits of
the z function.
Oh, yeah.
All right, give me the problem, or
F-
any problem, huh?
f of x equals 2x between 0 and 1. F of y is.
And zero else, right?
Yeah, 0 else. F of y is 1 over 2 between -1 and 1.
Is what?
1 over 2.
1/2 between.
-1 and 1.
Okay.
And then you want to find z.
And zero else. Yeah.
0 else.
In z, right? In-
Z equals x plus 3y.
Okay. I remember this. Right? 3y.
Yeah. And
All right.
then
Now, you all agree those two functions are clearly defined over a limited range. All right. Now, the thing about it is, the trick with this, we have 3y, we don't have y. So we need a variable, and it doesn't matter, I'm gonna call it g, is 3y. So I'm putting g down here. Now, it says this one is a constant over this range, right? So g has to be a constant over the range of what? 3y. Do you agree with that? So now g itself goes from -3 less than or equal to 3, and instead of 1/2, it's what?
1/6.
Y'all agree with that? And it looks like this for y, correct? Now we have to convolve those two functions. I'm going to do it pictorially because you could focus on the bounds if you want. But I think, in my opinion, it's much easier to draw the pictures so you can mathematically see you can see what's going on visually, and then just write the integral that's appropriate. So if you think about this, the way I tell people that always do convolution when I used to teach signals and systems, find the one with the most, let me actually put this down. This is going to be f of g now. And it's going to be 1/6 from -3 to +3. That's my new variable. All right, so if I look at this, the way you convolve things is basically you find the one that's got the most going on. In my opinion, it's this. It's not flat. So I leave that alone, and I graph that versus tau. And I have this, and this is at 1, and the height of this is 2 tau, correct? Now, take the other function and flip it, and then shift it. When you flip this one, you get something that would look exactly like this. It would go from -6 to 6, right? Right? This leading edge would be what? That's 6 minus tau, right? Or 6 plus tau, pardon me, 6 plus tau. And this is going to be tau minus 6. Do y'all remember that? We flipped and shifted. If we flipped it, it just goes from what? From -3, or -6. Hey, I said 6, it's -3, my bad. I'm sorry about that, I'm glad it got me. So it's 3 here, plus tau. So when tau is 0, it's already too late in the game, right? We need to bring it back. So when tau itself would be -3, you all see it? Mm-hmm. That's when this thing just starts to eke into it. So just it, right here, it would be, this is going to be 3 plus tau, but tau here would be equal to -3. That's when this window just starts overlaying this window. And we have to do the multiply. We have to multiply that times this, point by point. It's just this area that we have to integrate. Do you agree with that? Bradley, with me?
Yeah.
So what is that going to be? So we're going to say for what? For this, and actually this is Z. This is Z. I put down tau because usually convolution, tau is equivalent to Z. Do you agree with this, class?
Yeah.
All right, so for Z greater than -3, that's where it just comes in, but less than -2.
Where are the -2?
Look at where this thing, when does this point right here go to 1? When 3 plus Z equals 1 or Z equals -2, correct?
Oh.
So then you say -2. Right? If you look at this, what is my f of Z? Well, it's the integral of this, right? What is this? You'll notice what you're doing is you're going to integrate. Where do you integrate from? From 0 is where it starts, right? That's where this overlap begins. You asked that, didn't you? And it goes to what?
Z
To 3 plus tau. Or 3 plus Z, pardon me. You agree?
Alright, so it goes to 3 plus z. And what are we integrating? This is really gonna be 2z, correct? So it's gonna be, or, actually, I got it. This is actually, might as well make this tau, make it a linear. So that is going to be 2 tau times that density height, which is 1/6, right? Tau, and we'll put the limit there. And that comes down to what? That's 1/3, or it's 1/3 in t, so it's 1/3, 1/6, right? And here, it's going to be times 3 plus z squared. You agree with that?
Yeah.
You have the solutions for this, but you can see how it's just a methodical thing, right?
Yeah.
Now what happens? Well, it keeps going until what?
Back.
Now you go from -2 to what? Now just think about it. At -2, this curtain now shades that whole region, right? And it stays there till what?
So the back of it is
Which
one.
is,
4.
It'd be
Z
minus
equals
3.
so the back would be,
I mean, so
this is gonna be z minus 3, right? And
What?
this goes to what?
it'd be 3.
0, correct?
Wait,
So, or 3.
why does that make sense?
Well, the curtain's moving, but it's gotta spread a
Yeah, but
six.
when did the curtain go up to 1?
So you
Goes,
see,
no, the back end right here, because then, remember, as this
Oh,
back,
yeah, okay, yeah, I see it now, yeah, that
So-
makes sense.
let's go from z
Other half.
to less than 3. And then, can you all do this from here on out?
Yeah.
Yeah.
All right, now that curtain's moving here, and now we have to go from this point to this point.
Mhm.
And then finally, greater than 4. Y'all see that? And the total width of f of z, where it's non-zero, has to be the sum of the width of this thing, which is 6, and the width of this is 1, has to be 7. That's an important check. That's a good problem. I mean, those kind of problems, think convolution, cast it that way. The trick a lot of times is this, creating a function. I mean, suppose it was x plus y squared. Then you would say my g is y squared, and you would find the density function for g. Do you all follow me?
Yeah.
That's the trick on these things. Fair? Okay, we're over, but that's all right. That's a good problem.
How many G's do you know that are Y squared?
As many as are y cubed.
You got a lot of G's.
I've always had people like you. It's always, it's a joy to have people.
Hella G's.
I don't need an antidepressant, I got you. You know, I haven't had,
All his G's, man.
I think I told you about that one fellow I called cat narcolepsy that died, unfortunately. I had kids in my class, and I still do occasionally. Hadn't had one, I don't think, in the last couple of semesters. They'd come in and be sitting in the back, and I mean, they'd just be out. After about